So this is question 5. We have a coin which has been weighted. So weighted in this sense means that the sides don't have equal chance. So your probability of getting a head is going to be 2/5 in this case. Okay, so it's not a half. So this coin is actually biased. So this is a biased coin. And our chance then of getting a tail is 3/5. So we can see we don't have 50-50. So we know the coin is a biased coin. And we throw the coin 2 times. We want the probability of obtaining 2 heads, no heads, and at least 1 head. So I've already pre-drawn the diagram here. And we've got head, 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 tail, tail, head, tail, tail. So these are the 4 outcomes that are going to happen. So we can write those first. So we're going to get a head, head, a head, tail, a tail, head, a tail, tail. Okay, so we should add the probabilities on. So the probability of a head is 2/5. So we'll write that wherever we see head. So 2/5, 2/5, head here, 2/5, like that. And then a tail is 3/5. So 3/5 would be written where we see tail written. So 3/5, 3/5, and 3/5. So if we want the probability of getting 2 heads, we will multiply these fractions across the tree. So we're going to get 4 out of 25. Then we're going to get 2 times 3, 6 out of 25. Then we'll get 3 times 2, 6 out of 25. And 3/5 times 3/5, that's 9 out of 25 here as well. Okay, so just practice multiplying across the tree here to get these final fractions as the probabilities. So your first question is 2 heads. So we go to look at our diagram and then see where we have 2 heads, which is here. The probability of getting 2 heads will be 4 on 25. There's only one way to do that. So we'll get 4 out of 25 for your probability. No heads. Well, no heads is the same as having 2 tails, isn't it? All of these 3 here have heads in them, the top 3. But this one down here has no heads. So that's actually the same as probability of 2 tails. So we can write that as 9 on 25. And the probability at least 1 head, at least 1 head. Well, we can have 2 heads, that's fine. We need a minimum of 1 head. So that is going to be these 3 here. So if we write it out long way, so we'll have probability of head, head, plus the probability of getting head, tail, plus the probability of getting tail, head, like that. So we add those 4 fractions. So we got 4 out of 25 plus 6 out of 25 plus 6 out of 25. So 2 6s are 12 plus 4, that's 16 out of 25. So those are your 3 answers. 4 out of 25 for 2 heads, 9 out of 25 for no heads, and 16 out of 25 for at least 1 head. In question 6, we have a spinner in the diagram, and we're going to spin this spinner 2 times, so twice. Use the tree diagram to determine the probability of obtaining 2 reds, at least 1 red, and no reds. So this is our spinner here, and notice that we have 3 red colors, and we have 1 blue color on the spinner. So from that spinner, we need to work out our probability that any particular spin will get a red. So if we spin this, what's our chance of getting red? We notice that we have 3 reds on the spinner, and we have 4 sections that are equal size. So this is going to be 3 out of 4. And it's important that each of these sections are equal size as well. So as they are, then we can calculate this probability correctly as 3/4. So then for the probability of a blue is going to be 1/4 or 1/4. And these are the numbers that we include onto our tree here. So I pre-draw the tree and we see that we're going to have 2 spins. So let's call that spin 1 here. And let's call this spin 2 here. And from our spinner, each time we spin, we can either get a red or a blue. So let's put them in a circle there. And we can also get on the second spin a red and a blue. Red, blue, red, blue. So these represent the second spin there. And now we can label our probabilities. So let's put them on here in the green box. So our chance of getting a red spinner is 3/4. So we put 3/4 here. Wherever you see red, we'll write 3/4 like that. So red, 3/4, red, 3/4, red, 3/4. And for blue, we will put on 1/4. So blue is 1/4 here. Blue will be 1/4 and blue here will be 1/4. Okay, so now we can do our outcomes. What are they? And then get the probability of each outcome. So this first outcome could be red, red. The second one is red, blue. The third one is blue, red. And the last one could be blue, blue. So these are the 4 kinds of outcomes you could get. And now we work out our probability by multiplying the 2 fractions along the tree. So this will give us 9/16. We'll have 3/16 for this one. This one is also 3/16. And the last one is 1/16. So we get those by multiplying our probabilities along the tree. So once this tree is finished, we can use the tree to answer any possible question. So the first question is 2 reds. What's the chance of getting 2 reds? So we look at our diagram and 2 reds is here. And the probability of 2 reds is 9/16. So that's your answer for that one. At least 1 red means minimum 1 red. So looking at our tree, we have 2 reds here, which is okay because that's at least 1 red. So red, 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 blue, blue, red. So if we write it out the long way, this would be the probability of 2 reds plus the probability of red, blue, plus the probability of blue, red, like that. And when you add them up, you'll get 9/16 plus 3/16 plus 3/16. So 9 plus 3, 9 plus 3 is 12, plus 3, 15/16. So very highly likely you're going to get at least 1 red on this spinner. Okay, so no reds. Well, no reds is the same as getting 2 blues, isn't it? So we could write that as the same as having probability of getting 2 blues. So your chance of getting 2 blues is 1/16. So notice that B plus C, if you add these probabilities, you're going to get 16/16, aren't you? Because you either get no reds or at least 1 red. So adding these 2 will add up to 16/16. So that's the end of that question. In question 7, we have a spinner, and this spinner we spin 2 times. Determine the probability of getting at least 1 A, at least 1 B, 2 A's, or 2 B's. So these are the 4 questions we need to answer. So the first thing to do is look at your spinner and determine what the probability of getting an A is. So what's the chance of getting an A randomly on this spinner? Notice that we have 3 A's and we have 5 letters. So by random chance, your chance of getting an A should be 3/5. And by random chance, therefore, your chance of getting a B will be 2/5 because we have two Bs, 2/5. These are the probabilities we put on our tree. So we keep those in mind. So let's label our tree. So the first spinner, spinner 1 and spin 2 will be here. So we'll label as AB. So we've got A here. So you're either going to get an A or you're going to get a B for your first spinner. For the second spin, we're going to get again A or B, A or B. So we label like that. And then we put our probabilities on. So your chance of getting an A is 3/5. So this is 3/5. Your chance of a B is 2/5. And we repeat those numbers. So 3/5, 2/5, 3/5, 2/5. And our outcomes, what could we get? We could get two A's, couldn't we? Two A's, an AB. We could get a B, then an A, or then we could get two B's. So these are your outcomes. Your probability we get by multiplying your probabilities along the tree. So this is 3 3s are 9 out of 25. 3 2s is a 6 out of 25. 2 3s are 6 out of 25. 2 2s are 4 out of 25. Like that. So these are your 4 probabilities that you get from the tree. When you add them, you should check you get 25 out of 25 to make sure all probabilities are covered. So check that by adding the fractions here. Okay, so what's your chance of getting at least two A's? So when we look at at least one A. So when we look at our diagram, we've got two A's here, which is fine. We've got an A here, which is fine, and an A here. So you're going to have to add these 3 probabilities here. So we're going to have 9 on 25 plus 6 on 25 plus 6 on 25. So 2 6s are 12 plus 9. That's going to be 21 out of 25. So it's quite highly likely you're going to get at least one A when you spin this spinner. So at least one B, at least one B. So where is that? At least one B. Well, two B's is fine. And then these two here as well. So these are the 3 probabilities we need for that one to be at least one B. So that would be 6 on 25 plus 6 on 25 plus 2 B's, which is also fine. And that's 4 on 25. That's going to be 16 on 25 for the chance of having at least one B. 2 A's, well, then we just look at our diagram for 2 A's. So 2 A's is here. So that's 9 on 25. And 2 B's is here, BB. So that's not very likely because there's only 2 B's on the spinner. So of course your chance of getting a B then a B is going to be a little bit lower. So that's 4 on 25.